Okay, this is a video tutorial for lesson 9b part 2. This is operations on radicals. Make sure you've seen the lesson for 9b.1 or else there's going to be things that you won't be able to do. So it's going to be the same idea. It's going to be simplifying radicals, but then it's going to be applying some operation to that. These are the topics we're going to look at. We're going to look at adding, subtracting like radicals, unlike radicals, quotient, will be for dividing radicals, and then product rule, what happens if we multiply. So we're basically looking at the four properties that we apply to, operations that we apply to terms, but we're going to specifically do it for radicals. So when you're adding like radicals, it's kind of like doing 3x plus 4x. You wouldn't add these two parts together. You just say how many of these terms you have. So 3 add 4 is 7. So you'd say 7 radical 5, not radical 10. You don't add the 5 and the 5 together. Just like if it was 3x plus 4x, you wouldn't say it was 7x squared, hopefully. And if you're subtracting like radicals, so notice they have the same number inside the radical here. So 2 take away 3 is -1. Of course, we don't put in the 1 with -1. You just put a negative. So really what you're looking at is just the coefficients. As long as they're like radicals, that's really the important part about this. And then you can go ahead and try these questions here. So for the square root of 3 here, 2 plus 5 would give you 7. So this would be 7 square root of 3. As they're the same square root, 9 take away 5 is 4. So 4 square root of 7. And as they're both square root of 3, -12 plus 7 is 5. -5. So this would be -5 square root of 3. And you can type those in yourself to check. There's the calculator here if you want to check some of those numbers as well. Now, one thing you can do to check your answer if you want to. So on that first question, the question here is you can type the question in and you can get a decimal answer. And then once you think you have the answer, you can also type that in and check to see if the decimals match up. Also a technique you can also use if it's a multiple choice question as well. So simplifying and adding, subtracting unlike radicals. So notice this time 1 is square root of 3 and 1 is square root of 48. So we're basically going to take them, try and make them so they have the same radical. So we're going to have to work on this square root here, which is what we were doing last lesson. So we're going to simplify this square root and then see if we can combine terms. So I already typed it in. Square root of 48, you can see is this decimal here. So it's not a perfect square. So I had to type in include a table by plus, and then change this rule here to the number, which is 48, divided by x1 all squared. And then we start from this number here that we worked out, this 6.92, and round down. You don't need to take the round up to 7. Start from the number below, so 6. And what we're looking for, remember, is 2 whole numbers. If that doesn't work, hit enter, put 5, and then by that time, as soon as you hit enter, it should actually get to the next one. As soon as you find those 2 whole numbers, then that means you have your answer. Just to check this, I did actually type in 4 square root of 3, just to make sure that it is the same as the square root of 48, just in case I made a careless error somewhere. So once you've simplified this radical like you did last lesson, notice now that they have the same radical, and therefore you can just add the coefficients together. So 5 add 4 would give you 9. And I actually did type in the whole question, and what I think the final answer is, just as that one extra check, just to make sure that they are the same answer. And for the second question, square root of 50 plus 3 square root of 2. So this one's already simplified. This one's not. So we check the square root of 50, and then you fill in the value for the table. Once you've got 5 and 2, you can replace that, and then you can just add them once they're like terms together. If for some reason they're simplified to be like 5 square root of 3, then you wouldn't be able to add these together because they would still be unlike terms. So sometimes that happens, but most times they're going to ask you something that actually does simplify. Once again, I typed in the question and typed in the answer just to confirm that the decimals are the same as that extra little security to make sure I got them correct. And go ahead, you should be able to try these questions here. Go ahead and simplify the square root of 18, simplify the square root of 45, and simplify the square root of 12. And that should enable you to add the like terms together. And there's a calculator for you to be able to try that if necessary. That was the end of practice 2 and section 2. Section 3 is very similar, so we should be able to just continue here. There's no additional examples. Try simplifying the square root of 90. Try simplifying the square root of 72. Try simplifying the square root of 63. And once again, use those together. So section 2 and section 3 are very similar, just slightly more difficult on section 3 perhaps. Now, on that very last, on one of the questions on section 3, actually the first one in practice 3, if you want to check that answer, remember you can type in the question, and then once we've simplified the square root of 90 and we think it's 3 square root of 10, you can actually type that in and just check as well. Do we still have the same answer to make sure they're the same? And then on the last step, I just typed in my final answer just to make sure it was okay. So at each step of the question, you can actually check to see if your answer is correct when it's just numbers. Slightly different version, we've got a multiple choice question as well. So the question this time is both of these could actually be simplified. On the other questions, it was just one that could be simplified. We should always check to see if it does simplify further. So for this one, square root of 12, we're told is 2 square root of 3. 75, we're told is 5 square root of 3. And then if we add those together, which we can because these have the same radical here, you just do 2 add 5, which is 7. So I would want to select this one here. It can be simplified. I mean, we can only not add these together if these have different numbers inside the radical. All right, section 4 is the quotient rule. So this is talking about division at this point. So when we have the square root of a fraction, basically we split the fraction into two parts. So if it's 16 over 25, we really do the square root of 16 divided by the square root of 25. Work out each one independently, and that would be your answer. So for this one, you would work out the square root of 49, square root of x squared, square root of 36. Remember, for exponents, we're just halving the exponent. So luckily to begin with, all of these are even numbers, so that should make that a little bit easier for us to do. Now, one of those questions that you just saw in the practice section, if you wanted to check to see if that was the right answer, so I got the square root of 49 is 7, a half of 2 is 1, so that would just be x, and the square root of 36 is 6. If I type in what I think the answer is, and then I graph over the top, notice how it draws the same part of the graph. So that will confirm that it's right. But notice it's only to the right of the x-axis, y-axis. So actually, for this graph here, notice that it doesn't continue the same pattern. So for right now, we don't need to really know why that's true. But if you're looking at that, only focus just to the right of the y-axis and make sure that you get the same part of the graph. If the question gets slightly more difficult, as in part 5 here, if we have numbers and radicals, then kind of like numbers first, letters second, we'd want to do numbers first and then radicals second in this case. So you just times these two things together. So if they're two letters, you just put x and y. If these were numbers, you just multiply the numbers together and work out what that actually is. Just be careful though, that doesn't work for every term. That doesn't work for addition, for example. So square root of 2 plus square root of 3 is definitely not the square root of 5. This rule only works for when you're doing multiplication. So some questions you can just type in straight into decimals and it will actually give you an answer. Mainly here because the square root of 49 is 7 and then 3 times 7 is 21. But the questions can also get a little bit more complicated, like 3 square root of 80. So if we're simplifying this, you could check first of all to see if it is a perfect square. It's not for this case. And then you would just focus on this square root of 80 part. At the end of the question, we'll times it by 3. So square root of 80, we get our decimal. We use our table to come up with the right answer to find 4 square root of 5. And then now we can combine terms. So numbers with numbers, so 3 times 4 would give us 12. So you still have to do that simplifying part like you did last lesson, but at the end you just multiply by whatever number is at the start of the question. I normally personally don't even type into 3. I would just go straight to this step. And then if this is a whole number, I would just go ahead and times it by 3. And that should enable you to go ahead and try these questions here as well. Some of these you can type in and it'll give you the answer straight away. Others, you're going to have to go ahead and simplify those radicals. And then like the example, times by 3 possibly, times by 5, and then possibly times by 2 for that question as well. For one of those questions, you could actually see it did actually work straight away. So when you type it in, if you get 12, that's it. You don't need to do a table. Only when you get the decimals do you need to go ahead and simplify the radicals. If they work out exactly, square root of 36 is a perfect square because it's 6. And obviously 2 times 6 is 12. But sometimes with bigger numbers, that wouldn't necessarily be obvious. For the question 14, 3 times the square root of 75, see this was a decimal. So you just focus on the square root of 75, create your table, 75 over x1 squared, starting from 8, because it's 8.6, and then just count down till you get those two whole numbers. So I'm looking at 5 and 3 here. So I replace this with this, and then I just do the 3 times 5 to get 15. Notice at each step, you can also check that answer as well, just to see. So notice 25.98, and at the end, I also get 25.98. And 5 square root of 98. So I check first of all, doesn't work. So just focus on the square root of 98 for this one. Do your table again, count down from 9 this time because it's 9.8. As soon as you get two whole numbers, stop. So in other words, 7 and 2. and then multiply the numbers together because these are like terms. So 5 times 7 is 35 with the radical 2. And just go ahead and check that decimal again just to make sure this is the right answer. Be very careful if it is a multiple choice question because you might have the right decimal, but it might not be fully simplified, which is why it's really important that you do the table for these questions. Product rule, part 2, as we get a little bit more complicated here. We're going to do numbers with numbers and letters with letters. So 6 times 24, you check on Desmos. X to the 1 times by x to the 9. This is where you add exponents, giving you 10. And you can't type in the whole question in Desmos because this has letters in it, but you can certainly do the numbers part. So the square root of 144 is 12. And for exponents, remember, you just half the exponent. So a half of 10 would give you 5. If you want to check that answer on Desmos, this one seems to work just fine. So this one's good. So we can type in the question. As I click on the other one, notice how that graph reappears. This is why I'm only focusing on that first part. So there's the graph. And I can see that the first part of this one does actually match up. So I know that I'm good to this point. And then as I check that last part as well, ignore this part down here, but we can see this definitely overlaps. And if we're not sure, we can always switch off the first one. And you can clearly see now that it is exactly the same. Just look at, remember, just look to the right of the y-axis if you're going to do that. And that should enable you to do the same thing for this. Multiply the numbers, multiply the radicals, and then just go ahead and simplify like you did in practice 5. So we can check some of those answers. 10 times 40, I did on Desmos. Add the exponents, 1 plus 7 gives you 8. And then you can go ahead and simplify from here. Square root of 400 just works nicely. And a half of 8, because we're doing a half of the exponent, is 4. Same for this one, multiply the numbers first, add the exponents together, and then just go ahead and simplify each one. Square root of 100 obviously is 10, and a half of x to the 4 would just be x to the 2. And you can look through that last one and pause if necessary. So as we get into the last section, basically the same idea, but sometimes what happens if we don't get such a nice number here? So last lesson, what we discovered is you do half this number, but if it gives you a decimal, then the first part is the part that goes on the outside. And then the 0.5 just reminds you, you need to have a letter on the inside. So 6 times 24 is 144. 1 add 2 is 3. Square root of 144 is 12. And then 3 divided by 2 is 1.5. So I have x to the 1. And then the 0.5 reminds me to leave an x on the inside. And you could check this, of course, using that graphing method we talked about. Just remember to look to the right of the y-axis. Type in this, look at the graph. Type in this, look at the graph, just to make sure it's correct. Obviously, that won't get you the right answer, but it'll help you to check if your answer is correct. Oh, in fact, we even have it here. And you can see it gets slightly darker. Perhaps if I switch that off, it might be slightly easier to see as well. So a useful method to try. Just one of these for you guys to try this time. And here was my steps, just so you can check. 12 times 32 is 384. Add the exponents. 2 added 11 is 13. So that gives me this question. As I'm working out the square root of 384, you can see that it's not a whole number. So I create my little table, 384 divided by x1 squared. And then I just went down 19, 18, 17, and so on until I found 2 whole numbers, which was 8 and 6. So there's my 8. There's my square root of 6. And for the exponent, 13. 13 divided by 2 is 6.5. So the 6 of the 6.5, that tells me it's x to the 6. And a 0.5 just reminds me I still have 1x left over. And if you want to check that one, you have to type in x rather than n for the question. In fact, if I remember correctly, I accidentally put x here when I really should, of course, been using n's. So it should be 8n to the 6 and 6n. And hopefully you can just about see that it gets slightly darker. So that's a good idea that we've probably got the right answer for this question. And that finishes it for